I will try my best to handle it even when I don't see the screen. Can I ask you, how many of you know that there exists something called address sanitizers? Okay, so almost everyone. That's bad. How many of you know that there exist thread sanitizers? Okay, so that's maybe there will be something new for at least some of you. In my previous job, I was trying to solve a bug when I got a segmentation fault, and I was getting only logs from some remote device that I was unable to run debugger on. And address sanitizer helped me fix it. And when I asked my colleagues if they knew about it, they said, I don't know what it is. So I showed them that, and it was like, okay, that's a nice tool to know that it exists. It can, and in my current job, I also asked if somebody knew what it is. So you are more well known. So sorry for the ones who know already that it exists, but I think it's so much useful tool. So it's good to repeat that. I prepared some short demo where I will show you some of the kinds of bugs that it can fix. It is a compiler flag that can be run on all compilers, on SVC, Clang, and GCC. On Windows, there is limited support. You can only do address sanitizer. On Linux, you can do also leak sanitizer and thread sanitizers. I will show you both. Let's hope you will, at least some of you will learn something. This is my first lightning talk, so if I don't know how to structure it, I have a lot of examples. Maybe I will just show a few of them, and if you are more interested, I will show another ones. So I will firstly show, I will try to work it. Do you hear me? I will probably be trying to shout louder. This is, I don't think I will be able to talk to microphone and then look at screen. So here I have two compiler scripts, one for Windows, one for Linux. So I'll just show you how it looks on Windows. Here I am compiling with Clang. Okay. Here I am compiling with Clang and also with MSVC. That's, I don't know if how many Windows developers are there. Do you know that you can compile, just use the compiler directly, right? Or so this is just the shortcut for the compiler on Windows, and this is some compatibility mode for Clang that you can use on Windows. So you can put the same flags as you would do for the MSVC. And the only difference, here I am compiling with no sanitizer, and here with address sanitizer, and the only difference here is this fsanitize address, this flag. So it's really easy to add. The same for, so this is, it's actually looks very similar. Here, again, just flag fsanitize address. And Clang can also do fsanitize address use after return and fsanitize address use after scope. That's some extra checks. I will show you which bug it will be able to find after you have this allowed. And for Linux, so this is for GCC. Again, here just flag fsanitize address. And here on Linux, you can also specify leak undefined that should catch some undefined behavior. And again, there are some more additional flags for more cover, but the on GCC, this fsanitize address is quite good. And for Clang, it looks really similar. So this is just, you just add this flag, and then what I will show you what it can do for you. So here, this very simple example. I don't think it will happen to you that much, but here I have a number of elements in some global buffer, and I have accidentally typed less or equal instead of less. So when I run it without the address sanitizer, Okay, I have compiled it already, and when I run it without the address sanitizer, I will just print. It will print 5 elements, right? And I will show you what happens with address sanitizer. So here. So again, here without the address sanitizer, you see that it just allowed me to print it. There's definitely like it's not Stack Overflow, but something in the global. I don't know what's the storage called. And here I will do it with it. Okay, and I get this error message. So what's here? I will make it full. So it tells me what happened. Global buffer overflow, and it tells me on which, in which file it happened and at what line. And I also forgot to mention I'm compiling with debug info. If you have a debug info, you get this. Without the debug info, I don't think you will get exact information. And there is some more information that's not really, I have not digged into it enough. So, but this corresponds to how the address sanitizer actually works. So if you are more interested, you can look it up. And so we here, it's line 11. I will just double check it, but it corresponds to that. Here you can see it. Here, line 11. So it can detect global buffer overflow, stack overflow, heap overflow, use after free. I will show you that because that was the actually bug that was causing the segmentation fault. So again, let's look at the error message. So it tells me what happened, heap use after free. It tells me where it was freed and by what thread, and tells me where it was previously allocated. So, and again, it was the final error was at line 49. Let's check it. Okay. So we see it right here, so it checks. So again, what some maybe interesting thing, this use dangling reference on Windows with MSVC, it cannot find it. So let's just try it. So you see the address sanitizer have not caught it. But if I run it with the, I have compiled it with the extra options with Clang. I hope it's going like that. And now it caught it. So that's the reason for the extra flags that I've showed you before. I will just remind it. It's, okay, not this. It is here, this extra flag, or maybe it is this, I don't know, maybe it is this. So here for what the address sanitizer does, and for those who don't know about the thread sanitizer, show a quick example about the thread sanitizer. That works only on Linux. Here. So again, I have already compiled it. Noted. Sanitizer, just with VCC here. And which bugs it can help you catch. So here are just, again, some simple examples. Here we have a data race. So we have 2 threads that are incrementing something, and we expect that after that our shared counter will be 2 something something. So if I run this, what's it called, data race. Again, so it allowed me to run it, and if I run it with the sanitizer, I get some error message. I have not tested this that much, so I won't explain what's in here. But it's maybe if you are using multi-threaded program, multi-threaded application, this might help you catch some bugs. So again, another examples what it can catch. Race on heap. So this is just an example. This was on the stack or global values. This is on heap. This is race on container. So you are trying to push to the vector from do or the threads. And there is some locking. I've generated it by AI. And there is race use after free. Maybe I will try that just for a quick example. What's it called? Race use after free. So again, it caught something, maybe. So this is just a segmentation fault on a, okay. So it's at least something. And you might ask how what like extra overhead it gives. I have only tested for other sanitizer. From what I heard, thread sanitizer, the overhead is really high. So it's just only for some unit test, or maybe like you probably won't be able to debug or run your application with the thread sanitizer, but with the other sanitizer without optimizations, it's maybe 2 times, 3 times the cost. So that's actually not that horrible. So while you are developing something, you can try it on. And for the unit test or integration test, I think there's no reason why not to use it. And tak. Okay. So I have here a simple file that is compiling without optimizations and with optimizations and without sanitizer, MSVC and Clang. And then it's running some code. I will show you the code if you are interested. I can show you the code, what it's doing. I don't think this is really like representative, but it's just for a guess. So we can just look what it generated. So for MSVC with no sanitizer, it took this like sorting job took like this amount of milliseconds, and with the other sanitizer, so you can see it's like 2 times to 3 times more. For with optimizations, it took under half a second, and with other sanitizer, it took about, so it's still like 3 times to 4 times more. But the good thing is that you can run other sanitizer with optimizations. And with the Clang build, we see something really similar. So here it's like 3 times more. Okay, so I will just show you what it ran. So it's like some random benchmark that I made. So here it's like initializing vector and sorting it. Here it's like I don't know. I'm setting it. Okay. Here is just okay. So it has an array on a stack, and it's inserting some values into it. And here's trying vector pushback. So there is the number of iterations it took. It's like this is not like to show how it's like it's a very bad benchmark, but it's at least something. So I heard from I was listening to some big talk about it, big presentation, and he said it's about 2 times more, 2 times overhead. So I just ran these quick benchmarks. It's something, maybe it's more. So it's just some other tool. Some of my colleagues didn't know about it, so I thought it might be. So let's hope somebody at least learned something from it. So thank you for your time. And do you have some questions? Would you like to see some other examples run? Okay. So thank you for your attention.